Hi, I'm Rachel Bedaway and our project is Soy Extrusion.
And I'm Kelly Taylor.
Emily Johnson.
Okay, so for our process, what we did is we made a soy flour using raw soybeans. And the purpose of this was to create a gluten-free product that was low in fat for celiac disease patients. So our problem statement was basically just to figure out how the extruder ran and how much moisture and oil we wanted to get out of the soy flour. There's definitely a niche in the market for this for celiac disease patients. Celiac disease is on the rise. So that's where our market came from. And then basically the overview of our process, first we are going to put the soybeans in a dryer and dry them down to a moisture that we want. And then they'll go into the first extruder where most of the oil will be removed the first time. And then we will rehydrate those soybeans that came out as a product, put them into a second extruder to remove more oil, and then mill that into a flour and ship it out as a product.
So most of our lab experiments was focused on actually running the extruder and finding out the process variables. So here's the extruder we used. And the extruder temperature varies, and how well the extruder works depends on the moisture content of the soybeans. So we experimented with different moisture contents and to find out how high the extruder temperature would get up to, and then how much water and moisture would be removed based on the inlet moisture content, and thus how hot the extruder reached. So we found that the extruder ran best between about 7 and 9% moisture in the soybeans. And so we decided that since it was only removing around 5 to 10% of the oil, that we were going to run it through a second extruder to remove more of the oil to get a lower fat product. So we did that, removed some more oil, and that's kind of what designed our final process. So we discovered that we can remove about 40% of the oil being removed through extrusion to create a slightly lower fat soy flour. And then we basically went from that into the budgeting and capital stuff.
Okay, and for our budget, we started talking about all our equipment costs and how much it would cost to start up the plant, and that came about to be $1.8 million. And our production, we aimed to produce about 1% of the market share, which ended up being about 10 million pounds per year. And based on our total costs of production per year, and based on our analysis of how much we wanted to produce, that has allowed us to price our product at about $1 per pound, and that is very comparable to the market. For regular flour, it's about 60 cents per pound, and some of the higher or average cost for soy flour is about $3 a pound. So we were very competitive in the market. So overall, our payback period is less than a year, and our total production cost would be about $5 million per year for everything, and then our net profit per year would be about $4.6 million. There are also some alternatives to extrusion, and a lot of the soy is processed by an extraction method using chemicals, and so our process was to take away the chemical aspect of producing the soy flour into a more economical, beneficial to the environment. And this is also an idea for third world countries because it's a low energy processing method, and we have a way to capture in water loss as water waste so that we can put that back into our product. So it's a low energy cost, so it'll be good for third world countries investing in this, and it's very environmentally friendly.